So we proceed to regression. Analyze, regression, linear. That's what we are doing today. Linear regression, because our variables are continuous. So this is linear regression. So let me run one simple regression just quickly. This is our dependent variable. So our dependent variable is intention to use. So I put it here, intention to abuse internet. And I take only one independent. So usefulness. In this case, this is a simple regression because I have 1 against 1. Okay. So statistics, there's certain thing automatically tick. Please do not untick. Keep it there. And then you have to click few things. Please follow me. Remember, software is garbage in and garbage out. That's what it says, GIGO. Garbage in, garbage out. If you click, it will give you some results, but those will be not relevant to you. So you have to click only those are relevant. So descriptive, click that. Collinearity diagnostic, please click that. Darwin Orson, please click that. Case-wise diagnostic, please click that. I'm going to explain afterwards why we have to click it. I'll explain. Because this is simple regression, I don't want to spend time much here. I will spend time on the multiple regression, okay? So we click continue. After doing that, please click continue. Okay, so I've done that. And then now click on plots. Below statistics, you have plots. Then put the dependent under the Y box. And the next one to the dependent, put on X box. I'll explain why, don't worry, when I run multiple regression. Then click on histogram and click on normal probability plot. Then click continue. And then click OK. And you can see the output is there. Okay. So this output I'm not going to explain because I will do it during the multiple regression running time. Okay. It will be more meaningful. So all output is there. You can see within 2-3 seconds, the software has given you all the results. Now, those of you who are familiar with the statistics, like myself, when I did advanced statistics during my MBA course, to calculate R-square, when it takes about 1 hour time. And it has calculated so many times, so many things at the same time. So many statistical methods are run within the regression, okay? Can I proceed to multiple regression? If no one has a question, I'm going to explain more on the multiple regression. Is that okay?
Yes, sir.
All right. So I have just shown you, in case if you have one independent and one dependent, then we run simple regression. That's how we do it. So that was the purpose of showing you. Let me proceed to multiple regression. So we go to analyze, regression, linear, the same step that we have followed. Okay, and if you want to put reset, click on reset at the bottom. So all are out now. So everything we do it once. So intention to abuse internet is dependent. And these all are your independent variable. We put it under independent. Then we click again the same thing. Earlier we did descriptive. Those of you have taken note. Collinearity, Darwin-Watson, case-wise diagnostics. Okay. Why descriptive? It gives you the descriptive data, the mean, median, and all that for all independent, dependent variable, which is important. Collinearity diagnostic. This will give you the output, that the numbers that will help you to conclude whether you have multi-collinearity problem or not. That's why we click that. Darwin-Watson, why we click that? Because we want to see whether there is any autocorrelation problem or not. What is autocorrelation? I'm going to explain afterwards, don't worry. Case-wise diagnostic. automatically the standard deviation is set there as 3. Basically, what here we do is we want to see whether there is any outliers. If there is any outlier, for clicking this one, in the output, spaces will show you these are the items are outliers and must be dropped, must be taken out from your data. Okay, and that's why we click on case-wise diagnostic. Okay, so it will identify the case which is outlier. What does it mean by outlier? A data, this is completely out of trend. Say, for example, most of the respondents fill in the items 3, 4, 5, and one has filled all 1. So his data is completely out of trend. And this one data may corrupt your findings. So those has to be taken out, outliers, out of trend of your data that you have. So when you put this case-wise diagnostic, is going to identify the case supposed to be outliers, and there's a way of taking out the outliers. Okay, so that's why we click that. Okay, so now click continue. Then after that, click on plots, put dependent here and this one here. Why you do this? This one will help us to see whether there is any heteroscedasticity problem or not. What we want is, we want the responses to be dispersed, not concentrated. Not all responses are similar. Then we have a problem. Okay, so that one we will look at later. I will show you in the output how we do that. Histogram. Histogram will show you whether the data is normally distributed or not. This is one of the assumptions in regression. If data are not normally distributed, you cannot use regression. Okay, so and then normal probability part. This one will show you the linearity, whether the data were linear. Remember, when you click regression, you click linear. Okay, so the data got to be linear. So this one will show you whether data is linear or not. So don't worry, when we have the output, I'll show you how it is shown. Okay, so now click continue and then click OK. All right, you can see here when you run regression, it automatically runs correlation also, right? Automatically. And if you look at the mean at this descriptive table, out of 5, 3.2 for intention to use is like above normal, but it's still towards the agreeing side. Usefulness and ease of use is the most highest, right, in terms of ranking, in terms of the scale, more on the strongly agree side. Okay, that's how we do it. There is a reference, I cannot remember now, that gives you the benchmark of the mean. If your mean falls below 3 or below 2, then there is a problem. Okay, so you have to look at that. For this one, there's no problem because all of your mean are above 3. Okay, correlation, I'm not going to explain. This table I'm not explaining first. Let me explain the result first. Result. Where do we get the result? This one. Coefficient. This is the table that gives you the result where we can conclude whether your hypothesis accepted or rejected. Okay. This data actually, the student has a lot of data responses, but I use only 150. So the result may not be the way we expect. Don't worry, because this is just for running in the workshop purposes, the data I'm going to use. I reduce the data. And also it's not good to use, because this is original PhD data, I cannot use the full data, okay? That would be not very professional. So what I did, I reduced it and I used only 150 responses for running for this purpose. But if you follow Umar Sakaran and Christian Morgan table, the minimum requirement is 384 for this particular study. But I'm using only 150 just to show you how we run and interpret, okay? Now, which one should you see first? The first one we look at is significance level. This what tells you whether it is significant or not. So your dependent variable is down written there, intention to abuse internet. You can see that. That's why you don't see that inside the table. So usefulness here, There's a way of like marking it like red circle. I don't know how to do that. But it's okay. I think you can see it. You can see significance level usefulness is 0.533. Can someone tell me, is it significant?
No, sir.
It is not. To be significant, it has to be below 5%, up to 5%, meaning 0.05. Then it is significant. So this is not significant, meaning that there is no relationship between usefulness and intention to abuse. So this hypothesis is rejected. Second one, what is the significant value? 0.634, also not significant. Third one, compatibility, also not significant. So these three hypotheses are rejected. Now let's look at the next one. Attitude, is it significant?
Yes, sir.
It is significant at 5% significant level, right? 2.4%. It falls below 1%, then we say 1%. We have one. I will explain that. So this is significant at 5% significant level. This is number one. Once it is significant, immediately the next one we want to see is the beta. The beta is 0.237. Is it positive or negative?
It's positive, sir.
Positive. There's no sign meaning is positive. It's negative, it will show you the negative sign. Okay. So now it means that attitude has positive impact on internet abuse. Okay, so it gives you very good understanding. Even from common sense, we know whether you are going to abuse internet or not. It depends on your attitude. Okay, so if your attitude like you want to abuse internet, then you will abuse internet. That's what is the output of this. Okay, so it makes sense. So this is first one. So this hypothesis is accepted. Next one, subjective norm. Is it significant? 0.381? It is not. So next one, perceived behavioral control. Is it significant?
Yes.
Yes, sir.
Yes.
At what percentage?
0.7%.
No, 0.07. It is below 1%. So in this case, we will conclude this variable is significant at 1% significance level. Okay, so this is not 5%. Because this is below 1%. So we'll conclude that perceived behavioral control found to have significant positive effect on internet to abuse at 1% significance level or 99% confidence level is the same meaning. Okay, 5% significance level and 90%, 95% confidence level, same meaning. Okay, all right. So now we come back to beta. It is positive, so it's positive relationship. Okay. Okay. So first we see whether it's significant or not, and then we see it's positive or not. So we have done that. The third thing that we got to look at the beta value. Which one has the highest beta value? The attitude, right? The attitude, followed by perceived behavioral control, meaning you can rank now. Those have effect. The first rank, the most stronger one is attitude, followed by perceived behavioral control, followed by subjective norm. It was significant. It's not significant, so we are not going to rank it anymore. Okay. So those two are significant. Among them, the strongest significant variable is attitude, followed by perceived behavioral control. So if I use, say, for example, 400 data, the result will be different. And say out of this 6 variable, I got 5 significant, then I can rank them based on the beta value. Is that clear? Everyone, please.
Hello, Prof. Please, can I ask a question?
Sure.
Please, what is the difference between the standardized coefficient and then the standardized coefficients?
The standardized coefficient will take out the error without the error, and unstandardized one is with inclusion of the error that you have.
increasing of the standard error.
Yes.
Okay.
And that's the reason I'm using standardized one. I'm not using the unstandardized. Okay.
Okay, thank you.
Welcome. Is there any other question? No, huh? So I proceed. So this one, basically, we decide, make a conclusion, which hypothesis is accepted or rejected, which one has effect, first of all, significant level, looking at the statistically significance. And then we look at positive or negative relationship. And after that, even we can rank the variable, which one is having a stronger and lesser and all that, okay? Okay, after this, we should be looking at the R-square. That tells you how good your model is. Okay, R-square, basically, we call it as explanatory power of the model. Explanatory power of the model. Remember, I said I use only 150 responses, so the R-square bound to be low. And that is one of the solution. When you see your R-square is low, many students will ask, this question, how can I increase my R-square? So that is the clue. If you want to increase R-square, increase the number of responses. If you have 100, make it 200. If still R-square low, make it 300. Automatically R-square will go up, okay? Or the other way is to add one more variable or two more variable, okay, which is difficult because you have already collected data and all that, okay? You had a model. So better distribute more questionnaire, collect data, key in, and run it again after increasing of the sample size, okay? Now, R-square here is 21.1%. What does it mean? It means that the 6 independent variables that we have taken in the model, remember? Usefulness, ease of use, compatibility, attitude, subjective norm, and perceived behavioral control, the 6 variables I have taken in the model. These 6 variables can only explain 21% of internet abuse. Meaning that 79% or 78%, 79%, say that right? 78.9% factors have not been captured in this model. So in a way, we can say this model is very weak. If you look at the R-square. So this model can explain only 21.1% of internet abuse. Rest 79% has not been explained in this model. So what do? Is your study too bad? Not necessarily, because those factors you take it from literature review and with underpinning theories on all that. So later in your suggestion for future studies, that's where you will say that your study captured only 21.1%. So the future researchers should identify, the other variables that may explain, the user's intention to abuse internet. Are you following me?
Yes,
Okay.
sir.
Yes, sir.
Okay, thank you. So that is explainability. The explainability of the model, explanation power of the model. So this model power is only 21.1%. So now, some student will also ask me, what is the acceptable benchmark for R-square? That is a very difficult question to answer. For certain study, even I have seen 2% R-square and paper is published in Q1. And for certain study, 50% R-square is still, reviewer says, no, R-square is very low. How do you conclude that? We refer to the earlier studies, previous studies. If you find most of the studies in that particular area, R-square is low. If you are doing a study on finance, using stock market data, your R-square can never be more than 4%, 5%. Very normal. Okay. But if you're doing a study using questionnaire in management marketing, R-square expected even 40, 50% normal. Okay, if you capture good number of variables in the framework. Okay, so it does not mean you need to have a lot of variables in the framework. It means that you have to capture the right variable in the framework, and that will help you to increase the R-square. Okay, so this is the explainability of the model, the explanation power of the model. Okay, so this is the second one that I look at. The third one, Very important is the next one, ANOVA, after R². If the F is statistically significant here, anyone can respond. If the F is statistically significant here, in the ANOVA,
Yes,
if you can see, it is significant, right?
Yes, significant.
Okay.
it is.
If this is not significant, you are in big trouble. This one basically tells you whether you have an adequate model, whether your model is fit or not fit. So if this is not significant, it tells you that you do not have an adequate model. Therefore, your model is not fit. And therefore, the findings of this regression analysis cannot be used. So this has to be significant, okay? This got to be significant. So now, even though my R² is low, 21.1%, but my model is fit, so it's all right, it's acceptable. Are you following me?
Yes, Professor.
Yes, Prof.
Okay, thank you. So I have done the majority.
Please repeat, sir.
I'm sorry.
I'm asking you to repeat that.
Okay. The first one I have explained about looking at the relationship, right? So we look at coefficient table, and then we look at significance level to see whether it's statistically significant or not. Then I look at the beta values to look at positive relation or negative relation. And even looking at the beta value, we rank them. That one I have done it first. And after that, I look at R² to see how good the model is, the explanation power of the model. So we look at R². Okay. And then now we look at the ANOVA table. Here, the F significance level, the F got to be significant. If it is significant, it tells you, we can make a conclusion that we have an adequate model. The model is fit. Therefore, the findings of this regression model is acceptable. Okay. So if this F is not significant, meaning we did not have an adequate model, therefore the findings of this study is unacceptable. Is that clear, sister?
No, sir.
Yes, yes.
Who said no, please? Again, which part
Sir,
is not clear?
Sir, how could we judge that F is significant or F is not significant?
Looking at the significant under that 0, 0, 0,
Hmm?
to be statistically significant, significant value must be up to 0.05 until 5%.
Okay.
And this case is 0, 0, 0, meaning what is below 5%. Am I right, sister?
Okay. Yes,
Yeah.
sir.
As long as the significant value is up to 0.05, then we will say it is significant. If it is above 0.05, we will conclude that it is not statistically significant at 5% significance level.
Okay, sir. Thank you.
All right. Let me cover one more point for just a clue for you. Say, for example, I have 6. I'm now moving to coefficient table. I have 6 independent variables and only 2 significant. And there's another one is more than 5 but below 10%. Okay. I do not want to do something which would be bad for you to learn. I don't want to teach that. I can change the significance level here. I don't want to do that. Then you will learn it and you will misuse that. Okay, but a statistician can identify whether you have done some massaging with the output. Output can be even changed. It can be changed. But for me, if you change it, I look at the output, I can catch you immediately that you have massaged the output. Never do that. I'm not going to do that because I do not want you to learn how to change the output. I do not want. So let me just tell you, say for example, this one, subjective norm, this is 0.381. But say for example, it was 0.09, or say 0.3, not 30. So 0.081. If that was the case, since out of 6, we got only 2 significant. If I can make one more significant, it would be good, right? So subjective norm, if it was 0.081, then we would make a conclusion something like that. We can say the subjective norm was found to be not significant at 5% significance level. However, it was found to be significant at 10% significance level. It's under below 10, more than 5 but below 10. For many studies, we do accept up to 15%, but not many really. Not many reviewers will accept it. Not many supervisors will accept it also. But up to 10% is okay. If you found that most of the variables you got 5 and you got only one acceptable, and up to 1 to 5%. So, but you get another 2 up to 10%, then you can go up to 10%. And you can say up to 5% is significant, however, found to be significant at 10%. So the hypothesis accepted is okay. All right. Okay. So I have done the most important one, accepting, rejecting hypothesis, explanatory power, and your model is fit or not, acceptable or not. The 3 I have done it. So I have done most part of it. Now, the next one is for regression analysis. There are 5 assumptions that must be fulfilled in order to be your results acceptable. Okay, 5 assumptions, and I'm going to speak out now. Either you take note or later you will listen to the recording. Dr. Irfan will share, and this recording also will be available in my YouTube channel, so it's not a problem. Okay, so let me go through one by one. Let us start with normality. Okay, seeing this curve, do you think the data is normal?
Yes, sir.
Yes, sir.
It is normal. So the first assumption, normality is fulfilled. So data found to be normal. Okay, that's number 1. Okay, that's why we click histogram. Remember why I click histogram? I wanted to test the normality. Is this one linear?
Yes, sir.
Yes, sir.
It is,
Yes, sir.
because all
Yes.
those responses go along with the line. As long as it goes along with the line, it's okay. It deviate too much, then it is not linear. Okay, so that's the reason I put normal probability plot. Earlier I clicked that. I want to see whether data is linear or not. It is heteroscedasticity, scatter plot. Is the data scattered here?
Yes, sir.
Yes, sir.
It is.
Yes, sir.
If it is all concentrated in one